Hi guys, welcome to Eduxcite classes. We will continue from my previous video, that is work, energy and power. This is the part 2. If you have not watched the previous video, please check the link. It is given in the description. Okay, you can find out the PDF and the marking scheme. The link is of my website is given in the description. Even the complete unit A, the playlist link is given here in the description. You can check, and this is my QR code for WhatsApp. If you want to chat, you can scan the QR code. This is the same from our previous video, so just look at the formulas given in the data booklet. Now moving on to the very first question, pause the video and solve question number 6. Okay, so in the first part, if you look at the question, the work done by the force when the object has moved a distance of 10 meters. So this is the graph. You can see we know that the force versus distance graph, the area under the curve gives us the work. Okay, so the above the x-axis it will be the positive work, and below the x-axis it will be the negative work. So we have to take the sign into consideration. That is one of the most important aspect of this question. So if you will find out, we know that area under F versus D gives us the work done. Therefore, the work done by the distance of 10 meter will be half, base is 3, let us say this is 3 and height is 6. So this will be in positive, then negative, this will be the negative area. So this is a trapezium, and I hope everybody knows the formula for the area of trapezium, which is nothing but half sum of its parallel side. So this will be 7, because this will be 7 and this will be 5. So 7 plus 5 times the height, which is 4 perpendicular height. Now if you solve this, you will get the answer as minus of 15 joule. So this will be your answer for the A part. I hope it is quite clear. This is quite easy. If you didn't mention the negative sign, you will get 0 marks. Now the B part. In the B part, they are asking us the distance moved by the object when the work done by the force is 0. So there will be a point where, let us, this is 9, right? So if you solve this, this will be 9. So this is plus 9. So if you move in the negative side, there will be a point when it will be equal to minus 9. At that point, the work done by the force will be 0. At that, what will be the distance moved, that is what we have to calculate. So we don't know, let us assume it as x. So it travels an x distance from this part 3. I don't know where it will be, but let us say it is traveling a distance of x. So work done 0 means the work done above the axis, positive x, positive y should be equals to the work done in negative y, right? So work done is equals to 0, then I can say this will be equals to 9 minus of half. Now this is assuming as x, so I can say this as x plus x minus 2. So if this will be the length x, and if you look, this will be greater than 5, because this area is not greater than 9. So this is less than 9, so it has to be greater than 5. So I am assuming this, and the other parallel side will be x minus 2, because this distance is 2. I hope it is quite clear. If not, just let me know your comment in the section below. Okay, comment section. I will try my level best to discuss with you. So this will be 9 equals to, this will be 9, and if you solve this, it will be 1 by 2 times of 2x minus 2 times 4. This will be 2. So 9 equals to 4x minus 4. This will be 13 equals to 4x. So x will be 13 by 4. So this x comes out to be around 3.25, but this is from this point. So the total distance will be the distance at which you can say distance at which work done is 0 is equals to 3 plus 3.25, which is 6.25 meter. So this will be your answer for part B for question number 6. I hope it is quite clear. If you have any doubt, just comment below. Now moving on to the next, pause the video and solve question number 7. Okay, now if you look at this question, the box is initially having a speed of 5.6 and there is no loss of energy, no frictional forces are given in the question. So the initial energy will be only and only kinetic energy as it is at the ground level. Now it slides up and it compresses the spring and it becomes at maximum compression it is asking. At that point the velocity will be 0. So the final condition, there will be no kinetic but there will be gravitational potential energy as it gains height, as well as there will be elastic potential energy stored in the spring. So we have to find out the amount by which the spring has been compressed, where the height is given in the question. So it is nothing but using the principle of conservation of energy, which is nothing but energy is conserved in a closed system. The energy, total energy will be conserved. So initial energy will be equal to the final energy. Initial means initial state. The energy at the initial state should be equals to the total energy at the final stage. So I will just write half m v square. This is my energy initial, okay, and energy final will be nothing but half k x square, which is the energy stored in a spring where x is the compression, plus mgh, where delta h is given to us in the equation itself. Okay, now if you just equate these equation, half m v square is equals to half k x square plus mg delta h. So half m v square minus mg delta h is equals to half k x square. So just put up the value. Half mass is given to us in the equation is equal to how much? 4.2 times speed is given in the equation, which is 5.6, minus m is 4.2, g is 9.8, into h is 0.85, and this will be nothing but equal to half times k for the question is 2200 into x square. Now use your calculator. I hope everybody know how to solve this simple equation. You can just put up the values in your calculator. You will get x and two significant figures, something around 0.17 meter. So this will be the compression in the spring at the height as per the question. I hope it is quite easy. If you have any doubt, just comment below. Now try question number 8, pause the video and solve. Okay, now this is also quite easy one. There is a mass of 0.5 kg and a constant velocity of 0.3 on a level track, and this toy train is moving on a level track, and the power of the motor is 2 watts. So this is the power input, you can say, okay, and the total force opposing the motion is 5 Newton. Find the efficiency of the train's motor. Now we know that efficiency is power output upon power input, and if you want to convert into percentage, you have to multiply it with 100, right? Now power output, if we power input is given to us. Now power output in this case, power output is nothing but the force times the driving force times the velocity. It is given in a data booklet. The force is 5 and velocity is 0.3. So this comes out to be 1.5 watt. Now we have power input, we have power output, we can easily find out the efficiency, right? So the efficiency, this is the symbol of efficiency, so which is 1.5 over 2 times 100. So this is nothing but 75% or 0.75 in decimal. So the efficiency of the train motor is 75%. Okay, now for B, assuming the efficiency and the opposing force stays the same, calculate the speed of the train as it climbs 10 degree to the horizontal. Now this toy train is moving 10 degree to the horizontal and there is no change in the efficiency or the opposing force. So we have to find out what will be the speed. Now we know that if it is moving up on an inclined plane, there will be a component, let us say this is my toy train. So there will be a component mg sine theta downward with the opposing force, which is the same 5 Newton. So the total force, if there is no acceleration, because it is having the same same efficiency, so we can say that there is no acceleration, or you can say the constant speed. If it is supposed to move with the constant speed, there should be no acceleration, and if there is no acceleration, then I can say the driving force will be equals to the total resistive force. Now what is dF and RF? Again, I have discussed this in more detail in topic A.2 forces. You can check my previous video, the link is given in the description. Okay, now the driving force and resistive forces are the same, so driving force in this case will be mg sine theta plus 5, right? So the power power output will be force into velocity, so mg sine theta plus 5 times velocity, right? And power input will remain same, so efficiency is also same, so 0.75 is the efficiency, that will be equals to power output, which is mg sine theta plus 5 times v upon power input, which is 2. Now we know the value for theta, g and m, so total we can get the value for v. So if you put up the value 0.75, m is how much? 0.5, g is 9.8, and sine 10 plus 5 times v by 2. So solving this in your calculator, I have already done the calculation, you will get 0.26 meter per second. Now this has to be less than 3, because if it is moving on a inclined plane upward, it has to be less than when it is moving on a level road. Okay, so this is 0.3 and we are getting 0.26. So that is quite conceptually also correct. So I hope it is quite clear. Now coming to the paper 1 MCQ, just pause the video for question number 1 and solve. Okay, so we know the relation for kinetic energy and momentum. Guys, this is very important. Many questions are there from this particular relation. So kinetic energy 1 will be p square upon 2m1, kinetic energy 2 will be p square upon 2m2, right? Because momentum of both the object is same, it is given. Okay, so we can cancel out p square and p square, so it will be m2 over m1, simple. Yeah, so option A will be the right answer. Now pause the video for question number 2 and solve. Yeah, the question number 2 answer is B. Yes, so the EP, that is nothing but the potential energy, gravitational potential energy, has to be greater than the kinetic energy, because the ball is falling through an air, and due to air resistance there will be some losses. Therefore, the initial energy is always be greater than the final energy, because of the some energy will be lost during the process. Okay. But if there is no air resistance and nothing, then we can say energy for the gravitational potential energy will be equal to the kinetic energy. Now pause the video for question number 3 and solve. This is a very good question, and this has been asked recently in year May 2023, time zone 2, paper 1. You can check. This is a very good question. Pause the video and solve. Okay. Now if you look at this particular question, this object M is moving vertically upward and it has been accelerated, and that too with a constant acceleration. Initially the object is at rest, so initially the object is at rest and the final velocity reaches 4 meter per second, and the time for this is 2 seconds. This information is given and we are supposed to find out the average power output, guys. Now there are various different answers you will get using the different formulas for the power, but the average power output we generally calculate using the simple, because there will be changes in the energy here. So this will use energy per unit time. The power output, average power output will be energy per unit time. That is the definition of power, right? The work done per unit time or the energy dissipated per unit time. Now in this case, if you find out the energy gain, now what is happening, as the object is moving upward, it is gaining your kinetic energy also as well as gravitational potential energy also. So first of all, we can find out kinetic energy gain. So kinetic energy will be half m, v is already given, which is 4 square. So if you solve this, kinetic energy comes out to be 8 m, and gravitational potential energy is mg h. H is the delta h. Now how much height does the object gain in 2 seconds? Now for this you will use the Suvat equation. Now for delta h, I can say S is equals to ut, which is 0 because u is 0, plus half acceleration. Now acceleration will be change in velocity. Final is v minus 0 because it is at rest, and time is 2. So acceleration is 2 meter per second square. This is nothing but the constant acceleration. So half into 2, because I am using S equals to ut plus half at square, and time is 2 square. Now S is comes out to be 4 meter, right? And this S is nothing but the delta h. This is nothing but delta h. Now using this in this formula, so gravitational potential energy is g, I am taking as 10 into 4. So this comes out to be 40 m. So the total energy, if I ask you, total energy will be kinetic energy plus gravitational potential energy, which is 48 m. Okay, now this is final is energy. So total energy we got. So the average power output will be 48 m divided by time, which is 2, and this gets to be 24 m. Yes, option B will be the right answer. So I hope you got this, and please make sure you have to solve like this only, and the answer for this will be B only. Okay, if you have any doubt, just comment below, or you can just chat with me. The link is given in the description. Now question number 4 and the last question for this particular video. Pause the video and solve. Yeah, this is also recently asked in May 2023, time zone 1, paper 1. Okay, Now here if you see, the input power is given to us as 200 watt and it is used to raise a mass of 10 kg, that too at a constant speed, and the efficiency is 40%. We have to calculate what height will be the raised in 1 second. Now if you look at this, first of all, using the efficiency, can we find out the power output? So power in, this is power output upon power input. So power output will be 40% of 200, which comes out to be 80 joules. Okay. Now why I am writing joule is because we are doing for 1 second. So power output will be equals to energy in 1 second. So divided by 1 will remain same. So 80. So this 80 joule is used for the object to move upwards, right? Now this will be half, because it is moving upward, it will gain velocity half mv square plus mg delta h, or simply let us say h. Now if you say, like, let us say this object is moving with a constant speed v, in 1 second it will cover a distance of v only, because v is what, distance per unit time. If the time is 1, so the magnitude wise v will be equals to the length of the covered by the object. So I can write this v as h as well, because in 1 second magnitude wise this v and this h will be same, because they both are for 1 second and the speed for 1 second is the height and the speed is constant in the question. So I can rewrite this equation as half m h square plus mgh. Now we know the mass 10 kg, putting up the values, half 10 h square plus 10 g, I am taking 10 as h. So this becomes 5 h square plus 100 h is equals to 80. Simplifying the equation, h square plus 20 h minus this will be 16, right? Yeah, is equals to 0. Now if you solve this quadratic equation, nearly the answer will be coming near to 0.77. It will come 0.77 h, or h can be nearly 0.8 meters. So option B will be the right answer. Now we don't have a calculator in paper 1 previously, but for those students, they can just put up the values from the option in this particular equation and check which one is exactly nearly equals to 0. That will be your option. So option A, C and D will not get the answer near to equals to 0, but 0.8 when you put in this equation, you will get the expression nearly equals to 0, and therefore this is the way to estimate the answer for question number 4. But I think for this particular new syllabus, you are allowed to use calculator for your paper 1 as well, because you will have the experimental based questions as well in the other section of paper 1. Anyway, so I hope you got the answer for this question as well. If you have any doubt in any of the question, you can just let me know. Just a small request to please share with your friends and your classmates so that it reaches to the masses. Keep learning with me. See you in the next video. Take care. Bye-bye.